Hello guys, how are you? And today we are talking about the knapsack problem. I know you have a basic idea about the knapsack problem because when we are talking about the greedy approach, then we are discuss about the knapsack problem. What is knapsack? Okay, and so you know the knapsack means one kind of shoulder bag with the limited weight capacity, and there are few items having some weight and the value. Okay, so what is the main objective of the knapsack problem? Actually, the main objective of the knapsack problem is to fill a knapsack with the item such that we have a maximum profit with the crossing the weight limit of the knapsack. Okay, that means you can see the picture. These are the shoulder bag and some item are given with the corresponding weight and the values. Okay, profit value. And what are the main motto of the or objective is that the value of the profit we obtain the putting the item in the knapsack with the maximum to gain the maximum profit, and also the weight of the knapsack does not exist. Okay, so actually the knapsack problem are two variant are there. One is fractional knapsack and another is zero one knapsack. So already we have discussed about the fractional knapsack in case of greedy approach, applying the greedy approach to solve the fractional knapsack. And today we will discuss about the zero one knapsack and applying the dynamic programming we solve the zero one knapsack. Okay, so what is the what is zero one knapsack? The zero one knapsacks means as the name suggests, this item is individual. Okay, you do not break the item, and we cannot take the fraction of any item. That means you cannot take the fraction, or you cannot break the item. Okay, but in case of fractional knapsack we can break the item, but in case of zero knapsack we cannot break the item, and we have to either take the item completely or leave it completely. So that means you have to take either the item completely and put it into your bag, either and other than you have to leave the item. Okay, and it's solved using the dynamic programming. So these are the steps. So let's see how to solve the zero one knapsack problem using the dynamic programming. So consider the knapsack weight capacity, that is W. So this is the maximum weight of the knapsack, and some item of the in number of item having some weight and the values, corresponding values are there. So solve the knapsack zero one knapsack problem using dynamic program. The first step, sort the item based on their weight. First you have to sort all the item based on their weight value in ascending order. Okay, and after that draw a value table. Let's say the name of the table is capital V, and what is the size of the table? Actually the table means your 2D array, or you can say it's a matrix. So what will be the size of the matrix? So if you have n number of item and you have the maximum capacity W, then your size of the table will be n plus 1 and cross W plus 1. That means n define the row, that is the number of item, plus 1, this is your denoted the row, and the number of the maximum capacity plus 1 is defined by the column. So your value table is the size of n plus 1 cross W plus 1. Okay, and after that you fill all the boxes of 0th row and 0th column. You can see a 0, fill the first row and the first column you in 0. Why? Because when you have no item, that means you have zero item, so you have considered the weight is also 0. So you can see, first we generate the table of n plus 1 and W plus 1, that means n plus this is the row. So row starting from 0 end with n. Okay, that means n plus 1, 0 to n, that means n plus 1. And the column starting from 0 end with W, that means W plus 1, 0 to W. Okay, so first this is your 0th row and this is your 0th column. So when you don't have any item, that means your weight also 0. So that's why we fill all the weight value is 0 corresponding, and all the row now for the corresponding row, all the column is filled up by the 0, because you don't have any item, and so you don't consider any weight value also. And then go to the next step, that is your step 2. And step 2, we will calculate the value, we will calculate the value of V. That means in the step 2 we will calculate all the corresponding cell value, that is that means the index value of this cell is first row, first column. So 1 1, this is first 1th row and 2th column, this is 1th row, 3rd column, and this is nth row and wth column. So applying this formula, that is Vij, I denoted by the row and J denoted the column, corresponding column index, and I denoted by the corresponding row index. So after that you have to fill the corresponding cell of the V table with applying the formula. The how to get the value, the V of Ij, that means ith row and jth column, is equal to the maximum of V of Vth table, the previous row, that means I minus 1, and the same column index value, position index value, the corresponding position, with compare with the item value, the corresponding ith position, ith value is item value, and plus the Vth money, that means the corresponding table at I minus 1 at index position, that means row, comma, j minus weight of I, when ith position is weight. When we calculate and we find out the and compare this value with this value, then we get the maximum value and assign to the corresponding row. And these are the C code you can see. When the weight of the corresponding ith position value is greater than the j, then we assign the v of ij is equal to the same column but previous row index value. Okay, and when the weight of the ith value or ith position is less than j, then we applying this formula. So after fill up all the correspond cell of the corresponding the v table, then we move on to the step 3, and then we in the step 3 we find out the item, then which item you will select, then we get the maximum profit. So in step 3 we will find out the item, applying this formula. The formula is that I is equal to n and j is equal to w, that means your maximum number of items, and this is the maximum number of size of the knapsack. Then checking the if I and j greater than 0, and then comparing the v of I jth position value is v of I minus z position value, that means the same row but two different, sorry, same column, two different row value is same. Is if not, then we mm, update the jth value and the I decrement by 1. And if the both value is same, then that means the same column and different row, the position value is same, then we only just uh, in decrement the ith position value. Okay, so these are the steps. So let's take an example, and the complexity is you can see the n cross w, that means theta of n w. N is the number of item and w is the maximum capacity. So these are the time complexity of theta of nw. So let's solve the problem. You can see there is a example in the three different form, the same problem in given here in three different form. Here is a table, here we have mentioned some name of the item, and you can see there is no table, just give you the information, the maximum number of item, the weight of the knapsack, and the corresponding items weight and their profit value. Okay, so let's start the solution. So the knapsack capacity is 5 kg and the number of item given is 4. So in initially step 1 we have to generate the value table with the number of item here, the 4, that means the row size is 4 plus 1 5, and the number of column is 5. So sorry, the weight is 5, so the column size will be 5 plus 1, that is 6. So we generate a v table with 5 cross 6. The size of the table is 5 cross 6. Okay, and fill all the boxes of 0 and 0th row and 0th column, that means all are 0, and you can see these all values are 0. Okay, next go to the step 2. Then step 2, start filling the table the row wise. So if you start filling this table in the row wise and top to bottom. So row wise, that means first we take the position of the index position of v table is 1 1, the I value is 1 and j value is 1. Then the value of the ith position, that means the value of I is 1, so ith position item value, the ith position, these are the first item. So when the I is equal to 1, that means the first item. So first item corresponding weight is 2 and the value is 3. So the I, when I is equal to 1, that means the first item value is 3 and the first item weight is 2. Then using this value we calculate the v of 1 on a position, that means this position value, and then we get the value of v1 on is 0. Next we have to calculate the first row second column, that means 1 and 2. So the I is 1, that means the first item, and j is 2, that means the weight is 2. All these are the weight. and these are the items, that is 0 1 2 to n is the item. So I is equal to 1 and j is equal to 2. That means the first row and second column. Next, the value of first item and the weight of the first item. Also the value of the first item is 3 and weight is 2. Then we calculate and then get the v of 1 2, and similarly we have calculate the v of 1 3, v of 1 4, v of 1 5. That means we'll get all the column value of the corresponding the first row. Okay, and then we have to calculate the 2 2, v of 2 2. That means the second row and the first column. So now the I is 2 means the item 2. So now when we choose the item 2, then the value of item 2 is 4. You can see, and the weight of the item 2 is 3. That means this one. Okay. So applying the same formula and using this value, we will calculate and find out the value of the v of 2 1. That means the vth table is second row and first column, that is 0, and then we will calculate the second row and second column value, and then we will calculate 3, and so on. So similarly you can see we'll again applying the same formula for the second item. Then we find out all the value of the corresponding row, and then similarly compute all the entries. That means using the same formula, what is the formula, the using the same formula we just, and using same procedure, we find out, or you can calculate the rest of the corresponding row. That means the third row and fourth row, and then these are the final table. Okay, I'm not showing here the third and the fourth row how to calculate the similar, the same. Just we put the index and index value, the I just we take the index value I and j, and then find out the corresponding value of the item, the and the corresponding value of the weight of the item. Just put the value in the given formula, then find out the third and fourth row, and this is our final table. So we have already, now we generate the final table. So now the question is how to find out the item. So already you can see this is the maximum profit. So the fourth row and the fifth column, this corresponding cell, we find out always the maximum profit. Okay, so this column cell always gives you the maximum profit. So here the maximum profit is 7. Okay, for the given questions, and based on the same given item and their corresponding weight and the value, we calculate and then find out the maximum profit is 7. Now we have to find out the which item uh, you will select, then you will find the or get the maximum profit. So now let's see. You can see 7 is the uh, there is the fourth row and the fifth column. So next you have to search the, is there any 7 to the previous row? Yes, uh, the 7 is the previous row. That means this 7 is not generated for the fourth item. So that means the this 7, the this value is not generated based on the fourth item value. Okay, again I repeat. First you have to identify the maximum value, and always the value table, the this sale provides you the maximum profit. Okay, that is the last row and last column always provide you the maximum profit. After that you have to calculate the, or you have to find out the item. So which item you will select, then you will find out the maximum profit. Okay, so now the process is that first you can see this is the 7. So you have to search the row previous row of the same column. Is there any 7? Yes, there is a 7, you have already find out. So that means this 7 is not generating with the corresponding fourth item value. So the fourth item value is 6, so 7 is not generated based on the fourth item. So next we move up to the previous row, then again we search, is there any 7 to the previous row? Yes, we can find out the 7 in the previous row. That means this 7 also not generating based on the third item. So then we move up to the previous row. Then we have find out is there any 7 to the previous row? No, there is no 7 in the previous row of the same column. So now we finally find out the 7 is generated for the corresponding item 2. Okay, So the corresponding item to the value of the item is 4. Okay, so that means the corresponding item to the value is 4, and here the value is 7. So now we subtract the value 7 by value 4. Okay, then the remaining value is 3, and item, so we choose the item 2, that's why we tick the item 2. That means the value of item 2 is 4. Next we subtract 7 by 4, then we remaining value is 3. Next we have to search the, is there any 3 to the previous row? Yes, 3 is the previous row. Then we check, is there any to the previous row? No, there is no 3. So for the 3 is generated to the corresponding the first item. Okay, so the value of the first item is 3. Now we subtract this 3 with this, the value of the first item, and then we get the result is 0. Then we search, is there any 0 to the first previous row? Yes, there is 0, but there is no as such item is there, because there is no item, that's why the corresponding row value is 0. So we will find out the item, that is the item 1 and item 2. That means if we select the item 1 and item 2, we will satisfy the weight, that is the maximum capacity of the knapsack was 5, so 2 plus 3 is 5, and we gain the maximum profit 3 plus 4. Okay, so these are the result, and you can see the maximum value 4 plus 7. Okay, and the item is 1 and 2. Okay, that's all.